Hello everybody, welcome to Math with Mrs. Lehman. Today we are going to review, tomorrow is Math Wizard-a-thon 2018, and you guys are ready to do your best on your math test tomorrow. So a few quick things that I'd like to recommend to you when you get into your test. Well, obviously before your test, you're going to get a good night's sleep. Make sure you're not hungry when you come in. But when you get into your test, you are going to be given a reference sheet that you can use. So what you should do, probably, I think, is take that as an opportunity to write down all of the things that you can think of that you learned in different modules. So the biggest chunk of the test is going to be on algebraic concepts, so equations, expressions, solving for variables, substituting for variables, writing these equations and whatnot. And then also it will be Module 1, ratios, rates, proportions, and percent. So that is the biggest chunk of your test. So some of the things you might want to write down when you get there, line equals line, right? And then that's for scaling up or scaling down proportions. Another thing that you might want to write when you get in there is over of equals percent out of 100, all right? Or maybe you will see part over whole equals percent out of 100. Other things that you learned in Module 1, per is how you find a rate, right? A unit rate is out of 1. Let's see. You did learn a distance formula. Distance equals rate times time. And, ratios. There's three different ways to write ratios. So, for example, you could write them as a fraction, 1 to 2. You could write them as a ratio form with a colon, or you can write them with the word 1, with the word like that, 2, 2. Let's see, that was Module 1. Module 2 focused on operations and dividing fractions and stuff like that. So you might want to write down copy, dot flip. This is how you divide fractions. LCM, this is the first time, least common multiples, that two numbers meet and they fall in love and they celebrate their LCM. And then we have GCF, which is greatest common factor. You can find GCF using a factor tree. This is the saddest looking tree ever. Let's fix it. All right, so anyway, you have different things there you could use to remember. We started learning about the number line and positive and negative numbers. So 0 is in the center. On the right of 0, you're going to have positive numbers, and numbers increase as you go to the right. When you go to the left of 0, numbers become less and lower, and they're negative. I'm trying to think of what else we learned in Module 2. I think that pretty much sums it up. There were a lot of words that go with plus or positive numbers like gains and above 0 and above sea level, credits. Negatives would be debits, below sea level, losses, things of that nature. Let's see, Module 3 was about the coordinate plane. So you have the X and Y axis. You have 4 quadrants. You have ordered pairs that you plot X, Y. That's the standard format for that. That pretty much was the bulk of Module 3, I believe. Module 4 was getting into algebra. Expressions are math problems without an equal sign. Equations have an equal sign, so it's just a math sentence. So this is where you'd want to think of the different words that mean addition, subtraction, multiplication, division, and whatnot. I'm not going to write all those down. And then when you're looking at Module 5, you're going to be looking for things like the volume formula, length times width times height. You sometimes see that as base times height. You're finding the area of something. If it's a rectangle, it's length times width. If it's a triangle, it's base times height divided by 2, or area equals 1/2 base times height. What else did we learn? Yes. Oh, Good one. Kennedy just said if you can't divide or multiply, you must simplify. That's to help you with your proportions. So you might want to write that quote somewhere on this page as well. That's a good one. I'm trying to think of what else. That covers a lot. I mean, we talked about surface areas and nets and that type of thing, but just as a real quick guide for yourself, that literally took me 5 minutes, right? And that was with my lengthy intro and whatnot. So if you're willing to spend, a good 3-4 minutes of just writing things down that you simply remember, I think that'll serve you well as you get going and you maybe get a little flustered or something. Anyway, what we're going to do is go over some of the problems that you'll see. I know on my other video I started to review some of these, so I'm not going to redo the ones I've already done. This was in my first video, I believe, for Math Wizard-a-thon. That was also in there. I got a few questions done. This one was in there. This one was in there. They were very lengthy. Anytime you have a question, you're going to want to read it twice, underline keywords. This was definitely on a video because I goofed up the 5-to-2 ratio. Order of ratios is very important, as demonstrated by my mistake. All right, question 6. It says the table below shows the elevations at different artifacts. Shows the elevations at different artifacts were found. Does that make sense? Whatever. Anyway, during an archaeological dig. So this one says Arrowhead was 15 feet above sea level. When we see above sea level, that's a positive integer. Integer means whole number, right? So in this one, we found a bone at 721 feet above sea level. Sea level is going to be indicated by 0, and then above sea level, we have 400, I think that says 62. And then this one says below sea level, right here, below, so that's negative 1,200. This question is pretty easy. It says, write the name of each artifact and the elevation at which each artifact was found using a positive integer, 0, or negative integer. So all they want you to do is write like Arrowhead. That was positive 15. You'd go through and just list them all, right? So I think you get the point of that one. All right, we're going to move on to the next page and ask you to explain how you determined if it was a positive integer, a negative integer, or a 0. Okay, so anyway, explain how you determined if an elevation required a positive integer, 0, or a negative integer. So if you saw the words above sea level, I can't talk to it, above sea level, it's a positive. Below sea level were negatives, and 0 was sea level. So you would just put that in words on that line, and you would get full credit. This question's fun. It says a right rectangular prism has a length of 2.5 feet, a width of 3 feet, and a height of 1.5 feet. Unit cubes with side lengths of 1/2 foot are added to completely fill the prism with no space remaining. What is the volume in cubic feet of the right rectangular prism? So the first part of this question is pretty easy. What is the volume of the prism? So you need to know the formula. That's length times width times height. Right? Showing your work is very important on these part 2 questions. So you could have the correct answer and not have the work shown, and you would not get credit for that. So you really need to make sure that you're showing all of your thinking on paper. So has a length of 2.5, so I'm going to plug in 2.5 here. Has a width of 3 and a height of 1.5. Now, you guys should remember that when you are multiplying fractions, well, first of all, you would have a calculator for this, and again, you have a fraction button on your calculator, which I would recommend utilizing. But I'm going to go old school, no calculator, and convert these into numbers that have just a numerator and a denominator. You cannot have whole numbers here when we're multiplying. Okay, so the first one, 2.5, that would be 2 times 2 plus 1 is 5 halves times 3. You make any whole number into a fraction by putting it over 1, and then 1.5 would be 3 halves. Then your next step is just to multiply straight across the top and the bottom. Let's see, we have 5 times 3 is 15, 15 times 3 is 45, and 2 times 1 is 2, 2 times 2 is 4. So when you do that, you then need to change it back into a mixed number. So I have 45 divided by 4. That's going to go in there. You're going to subtract and get 0, bring down your 5. That's going to go in once. It's going to give you 4. So you're going to get 11 and 1/4. So the volume equals 11 and 1/4 cubic units, or cubic feet, I should say. So the volume is the volume is the volume. You cannot, like, they're trying to trick you right now by telling you the half-foot cube things. The volume of something is not going to change, like, depending on what you fill it with. The volume is going to be whatever the volume is going to be. So in this case, 11 and 1/4 cubic feet. So then the next question is, how many half-foot unit cubes can be added to fill the prism completely? This is where our answer is going to be a little bit different. So we had 11 and 1/4 was the volume. So I'm going to write that down, 11 and 1/4 cubic feet. Use what you know about unit cubes or side lengths to show your work or explain your answer. So pretty much if we have a 1 foot by a 1 foot by a 1 foot cube here, it would take 11 and 1/4 of those to fill that. But because we're filling it with half foot cubes, you're going to need twice as many to go the lengthwise. You're going to need to have twice as many to go the width, right? So you've got a total of 4 so far, but then you also need twice as many high to fill that up. So you're going to have a total of 8 cubes. So essentially you're taking that 2 and cubing it right here, this 2. So you need 8 times as many. So you're going to take 11 and 1/4 and multiply it by 8. All right, so again, I'm going to have 45/4 times 8 over 1. All right, you can go ahead and do that just straight across and then simplify, or you can simplify before you multiply, which I'm going to do here. So 4 and 8 share a common factor of 4. That's going to give me a 2 where the 8 was, so that's going to give me 90. So it would take 90 unit cubes. All right, so that's how you solve that one. The next page, a hotel has a number of meeting rooms M available for events. So you're picturing a hotel, it's got a bunch of rooms. Each room has 325 chairs. Write an equation to represent C, the total number of chairs in all of the meeting rooms. So we don't know how many meeting rooms, but we know each one has 325. So what you want to do is you want to take 325 times the number of rooms, and that's going to give you the number of chairs. So you have to recognize that you would multiply and then just write it algebraically. If M equals 7, use your equation to find the total number of chairs in all the meeting rooms. So you're going to take 325, multiply it by 7. All right, so you could, you know, they probably want you to do this. C equals 325M. Plug in what we know, 325 times 7. Right, these two numbers are being multiplied. And then over here, I'm going to multiply those. 17, 31, 21, 22. So the chairs that will be in that hotel are 2,275. That's a lot of chairs. And usually there's a line, but I made the font a lot bigger. So there it is. What did I say it was? 2,275. 2,275. Why is that not showing up? Chairs. All right, the next one. A company sells cereal in 2 different size boxes. The smaller box has the dimensions shown. The height of the smaller box is 80% of the larger box. So we know we've got another box that is bigger than this one. And it says the other 2 dimensions are the same for both boxes. So the height is going to change. In this case, we have a height of 12. We have a length of 7 3/4 and a width of 2. The other box, I'm just going to draw a picture of. All right, so this one's going to have a bigger height. It's going to have the same width. It's going to have the same length. But the height is different, right? We know that 12 is 80% of whatever this other one is. So what we need to do is write down what we know. We know that the smaller box is 80% the size of the larger box. All right, so we're going to call the larger box the 100% box, right? And we know that 80% is for the smaller box. We need to find the height of the bigger box, so we're missing that piece. So if you can't divide or multiply, you must simplify. So you simplify this down to 4/5, dividing the top and bottom by 20. And 4 times 3 is 12. 5 times 3 is 15. So that's step one. We figured out that the height of this box is 15. Right? And it says, what is the difference in the volumes of the two boxes? So we have to find the volume of each box first. So volume equals length times width times height. We're going to do the smaller box over here. So I would show it down below where I'm supposed to, but it's kind of hard to keep scrolling. So 7 3/4 times 2 times 12. And we'd have 31 over 4 times 2 times 12. And I'm going to simplify here to make that a little easier. 6 times 31. Well, doesn't everyone know that off the top of their heads? 6 times 1 would be 6. 6 times 3 would be 18. So we know that this one has a volume of 186 cubic inches. This one we have to find the volume for as well. And we're going to find the difference. 7 3/4 times 2 over 1. I'll just do that now. Times 15 over 1. So again, we're going to have 31/4 times 2 over 1 times 15 over 1. All right, so the 4 and the 2 can be simplified a little bit here. So I can divide this by 2, divide that by 2. 31 times 15 divided by 2. All right, so a little bit of math here. 31 times 15. 3 times 5 is 15. 4, 0, 5. Add them up. We have 195 over 2. 195 divided by 2. So 97 1/2 is the volume of this one. All right, so we've done a few steps. We still have one last step. We have to find the difference in the two volumes. So 186 and did I group something up? 15 times 31. I did times 13. Yeah, I grouped something up. Something's not right here because this was a bigger box and ended up with a smaller one. So I'm going to erase some stuff here. Oops. Let me use my really high quality editing software to delete what I just did. Oh, it's called an eraser. There you go. All right. So my bad, guys. I multiplied 13 instead of 31. I don't know. I'm reversing numbers. That's what happens on a Monday after a week off. So anyway, 31 times 15. Let's see if I can get this right this time. This is how you know it's an authentic video. All the mistakes, because the reality is you're going to make mistakes. All right, so 465 divided by 2. 465 divided by 2. 465. There we go. All right, so that's what happens when I hurry. Let this be a lesson to you, children. 4, subtraction is 1. So there we go. That one's actually bigger. All right, so 232 1/2. Wow. All right, so we need to subtract these. So 232 1/2 minus 186 is going to be what we need to do. So that's pretty easy. I'm going to just change it to a decimal. That's just going to make me feel better. 0.5, 186. So it is 46.5 or 46.5. Is there a line for you to write this one on? 46.5, or you could also write 46.5 cubic inches. That's how much bigger the large box is than the smaller box. Blah. Anyway, hopefully you're still watching. That's supposed to be the sound of someone snoring. Anyway, it's recommended that one fire extinguisher be available for every, oh, I gotta do this, for every 6,000 square feet in a building. So, write and solve an equation. So you have to write the equation, you have to solve the equation to determine the number of fire extinguishers needed in a building with that many square feet. So, you're pretty much taking your 135,000 square foot building and you're dividing it by 6,000 to see how many of these you're going to need. And that's going to give you X. So step one is to write that equation out. Recognizing that you're taking that amount of square footage, you're dividing it into sections that need fire extinguishers. So to divide this, I'm going to chop those zeros off. We have 3 zeros, so I'm essentially dividing each of those by 1,000 first to just get rid of those. And then we'd be doing this, which is dividing 135 by 6. Whoops, that's 1. 22. It's going to give you 12. I'm distracted right now. Alright, so and then you're going to get 3, 6. So you're going to get 22.5 fire extinguishers. Well, good luck going to the store trying to buy half of a fire extinguisher. You better make it 23 or you're going to be in trouble. Alright, so round that up to 23 fire extinguishers, which is somewhere 23 fire extinguishers. Alright, the next question, again, another ratio, proportion, rate, algebra. It falls into that main section. This one you have to substitute for a variable in an equation. So anyway, they tell you the formula right here of how to convert a temperature from Celsius to Fahrenheit. Your job is to just plug in what they tell you. It says the high temperature in a mountain city was 15 degrees Celsius. What was the temperature in degrees Fahrenheit? So you're going to have to do the steps you need to here. So in this case, this is more of a module 4 type question where you're substituting for a variable. So 1.8 times 15. Again, showing your work is very important here. So even if you use a calculator on this, you're going to want to make sure you write down everything you do. So 5 times 8 is 40. Did I do that right? All right. 9, 0, 8. Yep. All right. So 0, 17. So you have 1 decimal spot here, so move this in 1, 2. You're going to have 27 plus 32. Just go ahead and add those together. So 59. So the Fahrenheit temperature is going to be 59 degrees. All right. Common sense will serve you a lot with these types of questions, because if you get something that's like astronomically high and you know someone would be, roasting at that temperature, you might want to just double check your work. So 59 degrees is the answer there. 59 degrees Fahrenheit. All right. Oh, I love this question. It's about dogs. So we've got 2 people, Dana and Monique. They're dog groomers, and Dana's workday is 10 hours. Monique's is 8. Dana and Monique each work 40 hours per week. So we know that they are both working the same amount of time each week. It says on Monday, Dana groomed 15 dogs in 10 hours. I have to set up Dana, Monique. So Dana groomed 15 dogs, 10 hours. And Monique groomed 10 dogs, 8 hours. They each, or it says they each earned $12.75 for each dog groomed. And It says assuming that the rest of the week they groom the same number of dogs per workday as they did on Monday. So we're just kind of scaling up that ratio that they gave us until we get to a 40-hour work week. What will be their differences in their weekly earnings? So we first of all have to figure out how many dogs they were able to groom. So Dana is grooming at a rate of 15 dogs for 10 hours. 15 dogs in 10 hours. We want to figure out how many is she going to get done in the week, which is a 40-hour work week, which they told us up here. Dana and Monique each work 40 hours. So we have to scale this up. We're doing 4 times the amount, so 15 times 4 is going to give you a total of 60 dogs that Dana can do. So if Dana is doing 60 dog groomings, right? And we know that each one is how much? $12.75. Right? You're going to multiply those two numbers. So 6 times 5 is 30, carry your 3. 6 times 7 is 42, plus 3 is 45. 6 times 2 is 12, plus 4 is 16. 6 plus 1 is 7. I wrote 7 there. Why is that not writing? There we go. Why am I doing that? I don't need to do that. Anyway, I've got 2 spots here, so I got to move this in 2 spots. So this means that Dana is going to make $765. That's Dana. All right, Monique, she was doing 10 dogs in 8 hours. So 10 dogs for every 8 hours. We know that she's working the same 40 hours. All right, so she's going to scale that up 5 times. So she is doing 50 dogs. So she's a little bit slower than Dana. All right, so 50 dogs at $12.75 per dog. You know it's going to be less, obviously. So 5 times 5 is 25, 35, 37, 10, 13, 6. So she's making, did I do that right? Did I go something out? Usually I do. 7. Yeah, okay, looks good. All right, so we know that this is how much Monique made, and obviously she groomed less dogs, so it's going to be less. So we got to find the difference in them. So $765 minus $637.50. All right, so this is going to become 49. What am I doing? Jeez. Oh, I'm going home, kids. All right, bye. That was terrible. I don't even, like, my brain and my hand are, like, doing 2 different things. And it's not good. It's terrible. Let's see if we can subtract that again. So I'm going to make this $4, and that's 100 cents. This is going to be 50 cents left over. I don't know what I was doing last time. 14 minus 7 is 7. That's 2, that's 1. So $127.50 more is what Dana is going to make. 127.50. Let's see. Now another way of looking at that is we know that when we figure this part out, we know that Monique's only getting 50 dogs done and Dana's only getting, or she's getting 60, so that's 10 more dogs. If you take $12.75 and multiply it times 10, we're going to move that decimal over. So we know that it was $127.50 more just doing it that way. But in case you like lots of work, we can do it this way too. Yes. Yes. All right. Let's see. Oh, this is easy. A sandwich shop sells sandwiches. That is alliteration, kids. A sandwich shop sells sandwiches. Can you say that 3 times fast? Yeah, didn't think so. Didn't think so. All right. We thought the ELA test was over. Haha. This is a reading test all by itself. Anyway, so the sandwiches are $5.95 each. Is that good for a sandwich? Seems a little pricey for a sandwich, but you know, you go to McDonald's, it's more than that, so I don't know. The sandwich shop receives a total of $71.40 from the sales of sandwiches. Which equation can be used to determine the number of sandwiches sold? So you have to recognize that you are going to take which equation? Number of sandwiches. So if you know you made a total amount of money and you made $5.95 each, you're going to divide. So your answer should be 1. And now you're going to look and you're going to say, oh, well, you're taking $5.95 and dividing it by 71. No, that'd be like if they made $5 and they sold each sandwich for $71. That'd be insane. This one they're adding. That's not what we want. And then this other one that shows division is going to trick a lot of kids, choice D. But the correct answer is choice C here, because you're going to, what we kind of figured out is this. That's going to give you X, right? Well, if I want to get rid of this here, I would multiply this, right? That's what made that cancel. Anyway, so that you have to multiply the number of sandwiches times $5.95 each to give you that $70 that you earned. We're cranking right through these, and I have a phone call. Saved by the bell. Hold on. All right, last question I'm probably going to go over for today. It says, what is the area in square centimeters of the shaded part of the rectangle shown below? So you're not going to be able to do a whole lot with that without knowing. Here's how you approach this. You find the area of this outer rectangle, subtract out this section you don't want. Okay, so you're going to do area equals length times width. You're going to plug in 14 times 10. And you're going to get 140. That's the big rectangle, but we want to subtract out part of that. So the area of this triangle, that's going to be base times height divided by 2. Lucky for us, it's a nice right triangle here. We have 10 times, we know if this is up to 6, this missing piece must be 8. So 10 times 8 divided by 2, so we have 80 divided by 2. We know that's a 40 centimeter squared section. So if we take 140 minus the 40 we don't want, you're going to have an area of 100. Right there, choice C. I don't know, I could do one more, couldn't I? Yeah. Kids are like, oh God, we're sick of this. Alright, we're almost done with this. Alright, which coordinate grid shows point M plotted at 4, 3? So you got to go over 4, up 3. Clearly that is not choice A. That's for choice B is really goofy. Oh man, choice D. Let's hope D looks good. What? Let me go back. Which 4, 3? It's not choice A. Oh geez. Okay, it is choice B. Look at this. There's 4. For my angle, it looks like a 3. Anyway, it's choice B. Again, pardon the mistakes. It's like being here. Cool glasses. Talking to a kid in my class right now. Very diligently paying attention. Anyway, thanks for watching. I apologize for the mistakes, but it's been a long day. Yeah, it has been a long day. And it's flying by, but tomorrow we battle the math wizard. So anyway, good luck to you all. I know you'll do a great job. Mistakes are going to happen as demonstrated in the video. You just got to recognize when you make one and fix it, right? Best of luck to you all. Bye.